Hello guys, in this video we're talking about level order traversal again in binary tree. This is a third video. I think I make two videos already about this. The first video was about level ordering in terms of all path function, and this ordering works only when the nodes contain unique elements. And the second video was in terms of zip function. And in this video, in this third video, I will make this by constructing a new tree. So we have a tree of some which contains some type of values, and we will build a new tree from it which contain this value and a new value which defines the level on which each node is sorry, I fucking words forget this fucking word. I need to look at this. Okay, we have a tree of some type A, and our function will produce a new tree which contain a pair of this type A and some new type int, a pair of this A and int, and this int shows to which level this A belongs. Okay, so let's write type signature of our function. Okay, I will call it level function, level, and it takes some int from this is the number from which we start to count the levels of the tree. So if I want the first level 0, I will put 0 to it. Okay, and if I want to start from 1, I will put 1. So it as a first argument it take this int, and as a second, of course, it take this tree of some arbitrary type A, and it produce the new tree, but the first element is A and the second element is int, and this int show on which level this value of type A to which level it belongs. So if and let's look at our tree definition here. The tree of type A is either the empty tree or the node which contains this A and two trees. And of course, this is some new type definition. In the previous video I do a little bit definitions of the tree. It's some types of complete trees. Okay, we can see it here. I do these type definitions, but in this video I don't want to use this, because if we use this definition, we can't represent, for example, an empty binary tree or a tree which have only one child. So in this data type we can represent only binary trees which contain either 0 childrens, either 2 childrens. So let's come back to our level function. Let's define it in when the tree is empty. If we have some starting node, starting point n, I think it doesn't matter the first argument here, and we take this empty tree, and in this case we need to return I think we need to return the empty list, okay, or empty tree. So, but if we have some level, with n, and tree which constructed with a node constructor, and it has some value a and left and right subtree. Okay, what we do in this case? In this case we return a new tree. We constructed with node, of course, and as an element where will be pair. The first value is a, and the second value is this level, which they got from here, from this argument. So we start with the root, of course, our level, and if we push 0 here, we create a node with 0. Okay, and what we need in the left and right subtree? Okay, here and here we need to call our level function recursively again and push a new level. We increase the level by 1. We put n plus 1 here and left subtree, and at the right side we put n plus 1 again and right subtree. Okay, in the left and right subtree our levels are increased by 1. We go in one step down. Okay, these expressions will build a new left subtrees with pairs and right subtrees with pairs, and that's all, I think. Let's check this. Let's reload our module and let's run our. Let's first of all see it, our tr tree. Okay, here I create some tree. It's just binary tree of string, and at the root it has r0. It has 0 means that it's 0 level here, and it has left subtree and right subtree. Left subtree defined as some node with a root a1. 1 means it's level 1, and the right subtree start with d1. Okay, it's also level 1. And they have subtrees left, this left and this right. So here we have level 2, b2, c2, b at level 2 and c at level 2, and at the right side e at level 2 and f at level 2. Okay, and this is some tree. We can look at this. I do the derive and show for this data type, and I can see this as these constructions here. Okay, so let's our level run our level function for this tier tree, and of course I need to provide a start value from which I want to enumerate my levels, and we can see that I take tree which contains pairs, and this second argument is the level. Okay, and we can see that why there is a 0 here? Why there is a 0 here? I don't understand. Of course there is a 0 here because I always create a 0, but I need to create a node with level n here, of course. So let's reload, and we create a new tree. R0 at level 0, A1 at level 1, B2 at level 2, C2 at level 2, D1 at level 1, and e2 at level 2, and all work as expected. So we have a new tree here with our nodes marked with these labels, which define to which level nodes belongs. And we can easily derive the level order traversal. So traverse our nodes values in transform the tree of our nodes to the list, which order it in the level order traversal. How can we do this? Okay, we can simply at first step flatten our tree. We can flatten this with any order traversal, in order, pre-order, post-order. Okay, and let's write this function to flatten. I think let's call it flat. So it takes some battery of type A and produce a list of type A. So let's mark our first case. Let's define our first case. If we have empty tree, of course we produce an empty list. If we have a node, if we have some node, then we produce what we produce. We take our first A, and we need to flat the left subtree. Okay, we will receive a list, and we need to flat the right subtree. Okay, I think something like that. We build a new list and add the first node to this list using the const function to construct a new list. So I think this should work. Let's reload and try our flat50r. Okay, we can see that it flat our tree, but we don't want to flat our tree. We want to flat modify tree with our pairs. So let's do this. Let's call our level function with starting with 0 and tr and flat it, and we got these pairs. Okay, and now what we need to do, we have pairs, we need to sort all these pairs by the second element of each pair. Yes. And for this we have nice function. It contains in this module import data.list. It called, let's look at this function. It's called sort by. Okay, it takes some lists here and some function which define the order of two elements, and using it information, it sort this list and produce a new sorted list. So So we need to sort this function. This expression gives us pairs, and we need to sort these pairs sort by with some function which we need to define, and the second argument is our pairs. And how to define the sort function? I think this we define it with lambda. This lambda it takes two arguments, and each argument is a pair exactly. So I need to better match this. I first and second, and here's some lambda body, and the first argument, it's no matter what the first argument. I need only second argument, L1, and here I don't need the first argument, I need second argument. This is L2. Okay, and here I need to compare this L1 and L2 to produce an ordering, to compare two values which are the instances which have a type which have an instance in odd type class, and our int already have this instance, so we can use compare function to our L1 and L2. Okay, and I think this should work. Let's check this. You can see it sort me these pairs. So, and I don't want this element and for the second elements I don't want them exactly. I want just order my node values. So how can I do this? I have this list. The list is a functor. I can fmap this. I can fmap it to the functor with the fmap function, and fmapping function will be just first. I think yes. I need a first. Okay. Booms. And we get our tree in the level order traversal. Okay, using this expression. Let's copy this and let's define it as a function. I call it in order. It takes some tree and produce, and it will be defined as this expression. And I think this should work. We can write a type signature for it, but I can take it from E here. I don't want to think. Okay. In odd, in odd, it takes some battery of type A and produce a list of type A. Okay, should this work? Okay, I think this should work. Let's reload. Okay, it's compiled. And I can use our in order with a tr. Thanks, and it works. So guys, thanks for watching. Sorry for my English. Push like button, push subscribe button, write comments, and see you later in the next videos. Bye.